Welcome to our deep dive, all about getting ready for the AI 900 exam.
Yeah.
As educators and lifelong learners, we're going to tackle this material together. We're using the Microsoft Azure AI Fundamentals AI 900 exam guide to explore this exciting world of Azure AI. And it's really amazing to see how AI is moving beyond just like science fiction and into these practical applications that, well, that we can actually use.
Absolutely, yeah. This isn't just about passing an exam. This is about understanding how AI is, transforming all these different industries. And you can use that knowledge in your classroom and really in any area of your life.
So to get us started, why don't we lay out the main domains that we'll be talking about today? We'll be demystifying AI workloads. We'll be looking at the principles of responsible AI.
Hmm.
We'll master some machine learning fundamentals, and then look at Azure machine learning capabilities. And finally, we'll unveil the power of the Azure OpenAI service.
Wow, okay. That's quite a comprehensive overview. And within each of those domains, we'll be focusing on some of the critical concepts, real world scenarios, and some of the potential pitfalls you might encounter, and even some memory aids to help you remember it all.
Okay, sounds good. So first up, we've got AI workloads. So think of these as the different ways that AI can be used to solve different types of problems.
Okay, I see.
One example is anomaly detection. So it's kind of like having a detective that can spot unusual patterns in data.
Got it. Got it. So instead of like credit card fraud, let's say you're a manufacturer and you're using Azure AI to monitor your equipment. So anomaly detection could be used to flag, let's say, a sudden temperature spike in a machine, which could, indicate a potential malfunction.
Okay.
And that could, prevent, a costly shutdown. So thinking about it proactively can save time and money, resources.
That's a great example. Yeah, it really highlights how AI can be used to prevent problems before they even happen. So another workload is content moderation. So this is super important for online safety, especially these days.
Right. Well, Azure AI content safety goes beyond just text analysis, and it can
Yeah.
analyze images as well. So it's a really valuable tool for online platforms, and I think especially in education.
Definitely.
Just think about how this can help create a safer online learning environment for students.
Absolutely. And what about personalization? That seems to be everywhere these days.
Yeah, well, personalization uses AI to tailor those experiences, right? But it's not just about like suggesting products. You can use AI to create those personalized learning paths for students
Okay.
based on their strengths, their weaknesses, their learning styles.
Wow, that's a really cool application. And speaking of education, knowledge mining seems like, I don't know, almost like a game changer for research.
Yeah, it is. Knowledge mining uses AI to sift through those mountains of data that we talked about, like research papers and historical documents, to extract those key insights. Think of it as an AI-powered research assistant. It can answer all those really complex questions that, would normally take hours of manual effort.
Gotcha. Now let's move on to computer vision. So that's basically teaching a computer to, I don't know, see.
Right, like self-driving cars, that's a well-known example, but it's also used in healthcare, for example,
Okay.
for image-based diagnostics. Imagine an AI that analyzes medical scans and detects abnormalities, and it can do it more accurately and faster than humans.
Wow, that's incredible.
Right.
And then we have natural language processing, or NLP. This one deals with human language.
That's right. NLP powers everything from chatbots to virtual assistants and even language translation. In education, you can use it for real-time translation during those online classes, which makes learning accessible to a wider audience,
Oh, that's great.
breaking down those barriers.
It is. And finally, we've got generative AI, and that's generating quite a buzz lately.
Yeah, it is. Generative AI is used to create new content, and that can be anything from images to music to code. So instead of DLE, think about how GPT models could generate realistic dialogue
Okay.
for those educational simulations, and that's another way to create those interactive learning experiences.
That's a really cool application. Okay, so now that we've explored all these different AI workloads, let's shift gears and look at responsible AI.
Okay, sounds good.
So responsible AI is about making sure that AI is developed and used ethically. We need to address all those potential societal impacts. Microsoft has outlined 6 key principles for responsible AI, and those are fairness, transparency, privacy and security, inclusiveness, reliability, and safety, and accountability.
Okay, that's a good list.
Let's start with fairness. So how do we make sure that AI systems treat everyone fairly? And, how do we avoid those biased outcomes?
That's a great question. So imagine, for example, an AI system that's used for grading student essays. Now, if the training data, let's say, contains biased examples, the AI might unfairly penalize students from certain backgrounds. So, fairness in AI is about identifying and mitigating those biases so everyone has equal opportunity.
Okay, that makes sense. That's
Yeah.
super important, especially in education.
Right.
And transparency is really important
Yeah.
too, right?
Definitely. Transparency means that those AI systems should be understandable and explainable.
Oh, okay.
We need to understand how they arrive at their decisions, especially when those decisions have really significant consequences.
Yeah.
So that builds trust and accountability.
Now let's talk about privacy and security. So with all these AI systems processing huge amounts of data, how do we make sure that sensitive information is protected?
Well, protecting that data is, really the most important thing. It's not just about, complying with all the regulations. It's about respecting individual privacy. So AI systems should be designed with privacy in mind from the start. And that means using techniques like data anonymization and encryption to safeguard that sensitive information.
Okay, gotcha. So inclusiveness is also important, especially, as we live in a diverse world.
Absolutely. AI systems need to be designed to cater to the needs of all individuals, regardless of their background or their abilities. And this means considering accessibility, cultural sensitivity, and avoiding any design choices that might inadvertently exclude certain groups.
Yeah, that's really important. Reliability and safety are really crucial, I think, especially when we think about all the critical applications of AI.
Oh, for sure. We need to be able to trust that those AI systems will perform as expected, even in those unpredictable situations. And that means we need, rigorous testing, continuous monitoring, and incorporating mechanisms for error detection and recovery.
Okay. And finally, we've got accountability. So who is responsible when AI systems make a mistake or cause harm?
Well, accountability in AI is about recognizing that human beings are ultimately responsible.
Yeah.
For the design, development, and deployment of these systems, we need those clear guidelines, regulations, and mechanisms for holding individuals and organizations accountable for the actions and decisions of those AI systems.
Yeah, that's a crucial point. So we've covered AI workloads and responsible AI, which are really the foundation for understanding, Azure AI. Now let's dive into machine learning. This is really at the heart of many, many AI applications.
Yeah, machine learning is all about enabling computers to learn from data without explicit programming. It's kind of like, teaching a child to ride a bike. Instead of giving them a detailed set of instructions, you let them experiment. They learn from their mistakes and gradually improve their skills.
That's a great analogy. So how can we break down machine learning into key concepts?
Sure. Well, one key concept is features, and these are the input variables that the machine learning model uses to make predictions. Think of them as those clues that a detective uses to solve a case.
Okay. And what about labels?
Labels are those output variables. So that's what the model is trying to predict. That's like the solution to the mystery, the answer to the question.
Okay, so features are the input, labels are the output, and the machine learning model is kind of like that detective trying to connect the dots. Now, how do we make sure that the model doesn't just memorize the answers, but actually learns to generalize its knowledge?
That's a great question. That's where training and validation data come in. So we split our data into two sets, one for training the model and one for testing how well it performs on data it hasn't seen before. And that helps prevent something called overfitting, which is kind of like a student who just memorizes the answers for a test but doesn't actually understand the material.
Okay, that makes sense. Now, let's explore some of the common machine learning techniques. First up is regression.
Okay, so regression is used to predict continuous numerical outcomes. Let's say you're trying to predict the price of a house, based on factors like the square footage, the location, the number of bedrooms. That's a regression problem.
Okay, so regression is all about predicting a number. What about classification?
Classification is about categorizing data into different distinct classes, like an email spam filter.
Okay.
That's a classification model that decides whether an email is spam or not spam based on, the sender, the subject line, and the content.
Got it. So classification is about sorting things into different categories. What about clustering?
Well, clustering is about grouping similar data points together without any predefined labels. Let's imagine you're analyzing customer data for a grocery store. A clustering algorithm could group customers based on their purchasing patterns, and that might reveal, hidden segments like health-conscious shoppers or budget-conscious
Oh,
families.
wow, that's fascinating. It's almost like letting the data tell its own story.
Yeah.
And finally, we have deep learning.
Right. Deep learning involves training artificial neural networks. These are inspired by the structure of the human brain. Deep learning is really good at tasks like image recognition and natural language processing, where those traditional machine learning techniques, sometimes struggle.
That's incredible. So it sounds like deep learning is like pushing the boundaries of what's possible with AI.
Absolutely. Deep learning is really driving many of the recent breakthroughs that we've seen in AI, from self-driving cars to personalized medicine.
Wow. So we've covered a lot in this first part of our deep dive. We've explored the different AI workloads, the principles of responsible AI, and the fundamental concepts of machine learning.
That's right. And in the next part, we'll dive into the, practical aspects of building and deploying those machine learning models using Azure Machine Learning. It's Microsoft's powerful cloud-based platform for AI.
Well, I'm excited to learn more. So stay tuned for part 2 of our AI-900 Exam Companion Deep Dive, where we'll continue our journey into the fascinating world of Azure AI. Welcome back. Last time we covered AI workloads, responsible AI, and we really dove into the fundamentals of machine learning.
Yeah, we talked about all those key concepts like features, labels, and different machine learning techniques, regression, classification.
Exactly. So now I think it's time to get a little bit more hands-on. Let's explore how Azure can help us put all of those concepts into action. And that brings us to Azure Machine Learning, Azure ML for short.
Okay, yeah. So think of Azure ML as like your AI toolkit. It's a cloud-based platform where you can build, train, and deploy all those powerful machine learning models we've been talking about.
So it sounds like Azure ML can really take care of a lot of that, I don't know, the heavy lifting involved. What are some of the key components?
Well, it all starts with compute. Azure ML gives you a whole range of computing options. So you can start with those simple serverless setups, for quick experiments, or you can go all the way to those like massive clusters for training those really complex models.
So you can scale your computing power up or down depending on what your project needs. What about data? Those machine learning algorithms need data to learn, right?
Absolutely. Azure ML, it can seamlessly connect to all these different data sources. So whether your data is sitting in Azure Blob Storage or Azure Data Lake Storage or even on your local machine, Azure ML can access it, prepare it for training.
That's super convenient. What about environments? I imagine consistency is really important in machine learning experiments.
You're right. Environments in Azure ML, they ensure that your code runs the same way no matter where it's executed. They kind of bundle all those necessary libraries and configurations for your
So
project.
it's kind of like having a standardized lab setup for all your AI experiments.
Yeah.
Okay, I like it. And once we've trained a model, how do we actually use it? How do we put it into practice?
Well, that's where models come in. In Azure ML, a model represents that, trained intelligence of your algorithm, and you can deploy these models as web services, making them accessible for applications to make predictions.
So you could have a model that predicts customer churn or maybe
Mhm.
identifies fraudulent transactions, all powered by Azure ML.
Exactly.
Okay, very cool. And what about collaboration? A lot of times these machine learning projects are team efforts. So how does Azure ML handle that?
Well, that's where workspaces come in. Workspaces in Azure ML are those shared spaces where your entire team can manage projects, track experiments, even deploy models, all in one place.
That sounds like a great way to really streamline teamwork and make things a lot more efficient. Now, you mentioned earlier that Azure ML can simplify the process of building models. So how does it actually do that?
Well, that's where automated machine learning shines. AutoML for short. AutoML automates many of those tedious steps involved in building models, like choosing the right algorithm and, fine-tuning its parameters.
So it's kind of like having an AI expert assisting you with the model building process.
Exactly. You just provide the data, you specify the target you're aiming for, like, predicting customer churn, for example. Then AutoML tests a whole bunch of different algorithms and settings to find that, best performing model for your specific data.
Wow, that sounds like a huge time saver. So does that mean you need to be like a machine learning expert to use AutoML?
Not at all. AutoML is designed to be user-friendly. So whether you're a seasoned data scientist or just starting your machine learning journey, it really empowers anyone to leverage that power of AI.
That's fantastic. So it sounds like AutoML really kind of democratizes access to machine learning, which is awesome. Now, besides Azure ML, we should also explore Azure OpenAI service, right?
Right. Azure OpenAI Service brings the incredible power of OpenAI's advanced models like GPT and DALL-E right into Azure.
Okay, so what kind of capabilities are we talking about here?
Oh, it's mind-blowing. Think about things like generating realistic text, translating languages with incredible nuance. You can write different kinds of creative content, and you can even generate code.
It sounds like you can do almost anything with language. What about images? Can it create images as well?
Absolutely. So DALL-E, for example, can generate images just from text descriptions. You give it a prompt, and it'll create a unique image that matches that description.
Wow, that sounds, I don't know, like something straight out of science fiction. But with all this power, how do we make sure that these models are used responsibly?
That's a critical point. Content filters play a key role here. Azure OpenAI service has built-in safeguards to kind of detect and flag potentially harmful content.
So it's like having a safety net for all of that AI-generated content.
Exactly. And to really understand how these generative models work at a deeper level, we need to talk about things like tokenization and embeddings.
Tokenization, embeddings, those sound pretty technical. Can you break those down for us?
Sure. Imagine you're like teaching a computer to understand language. We need to break down the text into smaller units. It could be words or punctuation marks. These units are called tokens.
So it's kind of like dissecting a sentence to understand all of its individual parts.
Yes. And then each token is assigned this numerical representation. It's called an embedding. And this embedding, it captures the meaning of the token and its relationship to other words in that language.
Okay, so it's like giving each word a unique code that represents its meaning in like this multi-dimensional space.
Exactly. And these embeddings help the model understand those nuances of language and generate more human-like text.
That makes sense. Now, how do these models prioritize the most important parts of the input when they're generating output?
Well, that's where something called attention comes in. Attention mechanisms allow the model to focus on certain parts of the input that are, more relevant to the task at hand.
So it's like giving the model, I don't know, like a highlighter to mark those key parts of the text.
Precisely. And that helps the model generate more accurate and coherent responses.
Gotcha. Okay, so we've covered a lot about Azure Machine Learning and Azure OpenAI Service, but how are these powerful tools actually being used in the real world?
Well, let's start with image generation. So DLE, for example, isn't just for creating those fun images. Think about using it to generate product prototypes or even concept art for films. It could really revolutionize design processes.
That's incredible. What about text generation? I can see so many applications for that.
Oh yeah, absolutely. Imagine using GPT models to draft marketing copy, write personalized emails, or even create scripts for educational videos. The possibilities are pretty much endless.
So it's like having an AI assistant that can handle all those, repetitive writing tasks. What about music? Can AI create music?
Yeah, AI is composing music now. Imagine using AI to create soundtracks for videos, or even personalize music recommendations, or even collaborate with, human musicians on new compositions.
Wow, that's really amazing. It's like AI is blurring the lines between human creativity and machine intelligence. And these are just a few examples of how generative AI is already making an impact.
Yeah, and this is really just the beginning. We're only scratching the surface of what's possible with these powerful tools.
But we can't forget about those ethical implications, right?
Uh-huh.
We talked about responsible AI earlier, but it seems even more critical with these generative models.
Absolutely. The potential for bias in the training data is a major concern. If the data reflects those societal biases, then the model's output is probably going to perpetuate those biases.
So it's almost like, training a child with biased textbooks.
Yeah.
They're likely to learn and repeat those biases.
Exactly. So it's really important to use diverse and representative data sets and to be, really vigilant in mitigating that bias.
Another concern is misinformation. These models are incredibly good at generating realistic text, but what if that text is factually incorrect?
Yeah, that's a real danger. The potential for generating, fake news articles or even spreading propaganda is a serious concern. We need to develop techniques for detecting and flagging that synthetically generated content.
It's almost like giving someone a tool that can, mass produce lies.
Exactly. So we need to be proactive in developing safeguards to prevent the malicious use of these technologies.
That's a sobering thought, but, as we've seen, the potential benefits of generative AI are pretty immense. It's this powerful tool that can be used for good or for ill.
Right. Ultimately, it comes down to human responsibility. We need to guide the development and deployment of these technologies with ethical principles. We've got to focus on human well-being.
Well said. This has been a really insightful exploration of generative AI. But before we wrap up this part, there's one more, I think, crucial aspect we need to address. responsible AI considerations for these really powerful generative models.
Yeah, that's really important. While the creative potential of these models is amazing, we can't ignore the potential risks. It's about making sure we use this technology ethically and thoughtfully.
Absolutely. So how do we navigate these complex ethical waters? Where do we even begin?
I think one crucial starting point is data governance. The quality of the data that we use to train these generative models is paramount.
Right.
Garbage in, garbage out, as the saying goes.
So it's almost like building a house on a shaky foundation.
Yeah.
The whole structure is at risk.
Exactly. We need those robust data governance practices. That means carefully selecting and curating that training data, ensuring it's diverse, representative, and free from those harmful biases.
So it's like having a quality control team for your data, making sure that only the best ingredients go into your AI recipe.
Precisely. And just as important as the data itself is the way that we train these models. The training process itself can introduce or even amplify those biases if we're not careful. That's where techniques like, fairness-aware machine learning come in.
Fairness-aware machine learning. That sounds intriguing. What's that all about?
It's about incorporating fairness metrics into the training process itself. We can actually measure and mitigate bias. For example, let's say a loan approval model, it shouldn't discriminate based on factors like race or gender.
So it's like having a fairness watchdog, making sure that the AI is playing by the rules and that everyone is treated equally.
Exactly. But fairness-aware machine learning is just one piece of the puzzle. Transparency and explainability are also crucial. We need to understand how these models arrive at their decisions, especially in those high-stakes applications.
It's like having a window into the AI's thought process. You can see how it's making those judgments.
Precisely. So those explainable AI techniques, they can help us understand the factors that contribute to a decision and also help identify any potential biases or errors.
So it's about holding these AI systems accountable. It's not about blindly trusting their output, but accountability goes beyond understanding how they work. We need clear guidelines for their use, right?
Absolutely. Who should have access to these powerful tools? What are the ethical considerations for different applications? These are all questions that we need to grapple with as a society.
It's like developing like a code of conduct for AI, ensuring that its use aligns with our values.
Precisely. And those guidelines, they need to be dynamic. They need to evolve as the technology evolves. It's an ongoing conversation that involves, technologists, ethicists, policymakers, and, really the public as well.
So it's about shaping the future of AI together, making sure it's a force for good. This conversation about responsible AI is incredibly important.
It is. As we move forward with these powerful generative models, we need to be mindful of both the benefits and the risks.
And it's clear that we have a shared responsibility to ensure that these technologies are used ethically and, for the betterment of all of humanity.
Well said. In our next and final part, we'll dive deeper into those responsible AI considerations for generative AI. And we'll also explore how we can harness this power while mitigating those potential risks.
Okay, I'm looking forward to that. So stay tuned for the final part of our AI-900 Exam Companion Deep Dive. Welcome back to our final part of this AI-900 Exam Deep Dive.
Yeah, it's great to be back. We've covered a lot, from AI workloads to the fundamentals of machine learning and even the power of Azure machine learning and Azure OpenAI.
We have. And in this last part, we're really focusing on um, the responsible and ethical use of these, pretty powerful AI tools, especially as we go deeper into generative AI.
Right. We talked about those concerns like bias in the data and the potential for, misinformation.
Exactly. So those are some serious issues. We need to have strategies in place to deal with those risks. Where do we even start?
Well, I think the first step is just acknowledging that responsible AI isn't something you just tack on at the end. It has to be embedded in the entire process of AI, from development to deployment.
So it's not just about fixing problems after they happen. It's about designing and using these technologies with ethics in mind right from the start.
Exactly. And that begins with understanding what these models can do, the good and the bad. What are the benefits? What are the potential harms? Who might be affected and how?
It's like doing a risk assessment before launching a new product or, putting a new policy in place. We need to think about those consequences in advance.
Exactly. And in this risk assessment, we need to hear from a lot of different people. It's not just the engineers and data scientists. We need ethicists, social scientists, legal experts, and most importantly, the communities that might be affected by this technology.
Yeah, that's a really good point. It's about bringing different perspectives to the table and making sure we think about the broader societal impacts of AI.
Right. And this collaborative approach, it's important throughout the entire process. It's not a one-time thing. We need that ongoing dialogue and feedback to make sure we're staying on track and dealing with any concerns that come up.
So it's a constant process of evaluating and adjusting our approach as we learn more about these models and their potential impacts.
Exactly. Now, let's talk about some strategies for mitigating those risks. We already touched on data governance and fairness-aware machine learning.
Right. We need to make sure that data is diverse and representative, and that it doesn't contain harmful biases.
Wow.
And the algorithms themselves need to be designed to promote fairness.
Absolutely. And another strategy is transparency. The more we understand about how these models work, the better equipped we are to find and address potential problems.
Transparency is really key for building trust and accountability.
Exactly. Now, this doesn't mean we need to share every technical detail about how the algorithms work, but we do need to be able to explain the decision-making process in a way that people affected by those decisions can understand.
So if we have an AI system that's approving loans, we should be able to explain to applicants why they were approved or denied. And that explanation needs to be clear, concise, and easy to understand.
Exactly. And that leads us to another really important concept, human oversight.
Human oversight. So we're not just letting AI make decisions all on its own.
Exactly. Especially when the stakes are high, human oversight is crucial. We need humans involved to review those AI decisions, to provide context and judgment, and to make sure ethical considerations are being upheld.
So it's really a collaboration between humans and AI, where each brings its own strengths to the table. AI can process all that data and find patterns, and humans can provide the ethical framework, judgment, and empathy.
Right. And this collaboration, it needs to continue beyond development and deployment.
Right.
We need ongoing monitoring and evaluation as well.
So we're not just launching these models and hoping for the best, we're constantly checking how they're performing, looking for potential issues, and making adjustments as needed.
Exactly. And this monitoring, it needs to include not just those technical metrics like accuracy and efficiency, but also those ethical considerations. Are we seeing any bias in the output? Are there any unintended consequences?
It's about being proactive, recognizing that responsible AI is an ongoing commitment.
Absolutely. As we wrap up our deep dive into Azure AI, I want to emphasize that this is just the beginning of the journey.
There's so much more to learn in this field, especially since it's changing so quickly.
Right. And as you keep learning, keep these principles of responsible AI in mind. The future of AI is being shaped right now, and we all have a part to play in making sure it benefits all of humanity.
That's a great point. And to our listeners, thank you so much for joining us on this deep dive into the world of Azure AI. I hope you found it helpful and informative.
I encourage you to keep exploring, keep learning, and keep the conversation going about responsible AI development.
Until next time, keep diving deep.